Hello, today I will talking about how can we divide the soil into soil layers. So today I will give you one of example. The example of my example is the boiling log or boiling report. It's a raw data. So I would like you to classify the soil into layer by layer. So the result is something like this. Is the result of the typical result of the soil boiling in Thailand or in the other country. Also, it might be something like this. So what should we start? We see for the first column. First column is starting with the type of the soil sample. They have the SS. SS is stand for what? SS is stand for split sample. ST is for Shelby-Tube. So what is split sample? Is the sample that we collect the soil by we blow the sample to collect the soil, and the wall of split sample is quite thick. So the soil we collect from this kind of test is this type of soil. When we using the split sample, we will get the result from SPT. Is the N here. N here is SPT 33, 25, 24. This one is N is rows per foot. And after 5 meters, they starting to collect the sample by using the ST. ST is Shelby-Tube, or we can call it thin wall tube. The thin wall tube is a sample that we collect the soil. The quality of the soil is better compared to the split sample. And the thin wall tube here, we can get the result from the unconfined composite strength test. We have the SU, undrained shear strength. And after the 15 meters, they change the way to collect the sample by using SS. SS, if you should use SS, you will have the result from N value is SPT is rows per foot. Is that clear about here? And also in the second column, they will tell you about the depth that we collect the sample. The depth for collect the sample is, for example, SS number 2 is the depth about 3 to 3.5 meter, and the rest they have the index properties of soil, such as water content, unit weight, the passing to seed analysis. They have the seed number 4, number 200, and they have also have the Atterberg limit, liquid limit, plastic index, and have the soil classification. If you guys forgot about the soil mechanics, my recommendation is go back to read from soil mechanics, or I just heard they have the online course of soil mechanics. You can go back to read to study again what's going on, what is the call, what is the meaning of liquid limit, plastic limit, and plastic index. And also you have the engineering properties is the SU also. So how can we start? What should we do first? My workflow is something like that. I will start with the testing method first. Okay, SS first, ST. Okay, first testing method. So I grouping as the first layer. I'm not quite sure. Maybe it's not the case. Something like this. Okay, it might be something like this. We see from the ST first. Okay, SS we come back later. We're talking about this, the SS altogether, yellow and pink one. ST we collect the sample. The sample we collect from ST, we collect the so-called undisturbed sample. So when we collect undisturbed sample, we can obtain the water content. It's clear. We can obtain water content because we collect by Shelby-Tube. We seal the tube by the wax, and we transport the tube to our lab, and we extrude it, and we test for the water content. So if I have the result of the ST, I will start with So first I will start with the water content. Actually you can start with the SU also, but you can see it's around here. SU is not test of every sample. Some sample test is missing, so I first start with water content. According to water content here, you can see from this to that one. That one, in my idea, I think it's quite the same. This one is a little bit bigger, it's a little bit change little bit, but I think it's okay, only one sample, so I can grouping. This one is my first layer. It's about here, should be first layer to be my first gray layer, and that's about about it here. Sorry, change this one to be this one also. This one is first layer, so you can see the water content is quite the same. So after you get this one first layer, we have to go to back to see the next information. What kind of soil? As I mentioned before, we have to know, to select if your soil is clay or sand. How can you know clay or sand? We look at the sheet number 200. It's passed through number 200 about 100%, 99.8. So this soil should be clay. Clear? Your soil is clay. So if your soil is clay, you have to calculate the undrained shear strength, because we assume that our clay is undrained. How much of undrained shear strength of clay? They have the result of undrained shear strength 1.5, 1.7, and how much is about 2.2 tons. So we just average. Okay, and then just sorry, we move to this. So it should be so, and then shear strength here is about 1.85 tons. So I multiply with 9.81, change to be units is kilopascal. Okay, our first layer is clay. Red, so I change to be the same color to more on the side. Okay, this one is clay. Is that clear? Okay, we go back to this layer. We collect the sample by using ST. ST, that means the quality of sample is not good and your sample might be disturbed. That means the moisture is lost during transportation, so water content cannot use anymore for SS. I talk about this one again. Water content is not work anymore for SS because this sampling you might lost the moisture during transportation, or it's lost the water content during you take the sample off the tube. So if SS, I starting to see, I see from N. You can see it here. Sorry, it should be the same or similar. Just change to be, it should be the same. So what kind of soil? You can see that it's passing number 200, about 40%. So it should be 40% should be sand or fine grain. Is that clear? That one. So for the sand, we have to calculate the friction angle. Friction angle we calculate from N or SPT here. where is my SPT? Okay, SPT is about here. Actually, we have two methods that I teach you before. How can we calculate the SPT? So how can I calculate for SPT? In this case, I will use Peck approach. So firstly, we have to check for n correct. If n is more than 15, you have to make correction or we have to reduce before we use this curve. So we go back to our Excel. N correct. Okay, n correct here is about what? Is about, firstly we have to determine an average of this. Okay, this one is an average, so we have to make the correction. How can we make the correction? Is this one minus 15, I think you can remember, minus 15 over 2 plus 15. So the n correct here is about how much? Is about 19.5. So go back to see where is 19.5. 19.5 here. Okay, I just draw some line. 19.5 is about here. So how much for n value? It's about 33. It's about, sorry, it's a friction angle is about 33. Okay, quite straightforward. Okay, so we go to the next one. Next one is SS. As I mentioned before, that if we use SS or spray sample, we cannot use the water content anymore. We just use the N here. So what's going on about the N? Okay, this one is my first layer, should be maybe, oh, should be first layer, maybe here should be black. Okay, and the rest is okay. So we start with N value. So what kind of soil? From this to that is passing through number 200, more than 50%. This one 56 is still more than, so this one should be gray. And the rest, the passing number 200 about 27, 47, 32. So this one should be sand. Is it clear? So if it's gray, we have to calculate the value of the SU. So have to determine average. Average here, average from this to that. Okay, n here is equal to n average equal to how much? It's about 32. So we have to calculate for SU of this gray. SU of this gray is equal to n without any kind of correction multiplied with 5. Clear? N multiplied with 5. So SU is something like this. Just make this easy to read. Okay, this one is SU in kilopascal. So this is, and the last one is sand. So first one you have to make the correction. Average first. Average of this one. And what do next? I have to make the so-called correction, correct and correct. Y by 2 plus 50. Incorrect is about 28. So if we go to 28 from our graph, 28 is something like this. It's going to be the green one. 28 should be around 35. Okay, it's quite straightforward for do this. We still have the other column that we have to calculate it. If we collect the sample by using the SS, where is our unit weight is around here, so it's equal to average again. This one, the SI unit multiplied with 9.81. Okay, and we have the results from sand. As I mentioned before, when we collect the sample by using SS or split sample, when we remove the sample from the tube, the moisture is lost, totally lost, and the sample is not formed like a shape, so we cannot obtain any kind of unit weight. So how can we know how much for unit weight of sand? If we don't know, we have to what? We have to assume. The lower bound that we can assume unit weight of sand, we always use this number, is 18. Okay, it's work for Bangkok sand. This one is the medium sand. It's not loose. And the last one is still sand, but we have little bit results about the unit weight, about 1.96, 1.87. We can use the average of this one also. Okay. Maybe you might have the question, that's why I can use this, because the unit weight that if we bring the sample and we obtain from the lab, the unit weight of the sand should be is lower than the actual one in the field. Maybe the actual one in the field is not like this. It's maybe a little bit higher, should be 19 or 20 or something else. But if we use the low value of unit weight, it's quite conservative, because if we use the lower of the gamma unit weight, that means we obtain the low value of effective stress. If low value of effective stress, the strength that we use to calculate is lower than the actual one in the field, is safe or conservative. So that means we can, for SS, we can use the unit weight from the lab result, or we can, if we have no lab result, we can assume. If you do something like this for my midterm exam, actually it's not finished. You have to do the other things also, because they have clay here, sand here. You have to tell people that it's soft clay, really soft clay, or stiff clay. You have to tell the people also. You have to add the prefix. How can you add the prefix? SU here is equal to 18, about 18 kilopascal. 18 kilopascal. Go back to C form. I have one table about 18. Okay, they have the in this table is not SU is unconfined shear. So that means if you would like to obtain SU equal to QU over 2 or QU over there equal to 2 times of SU. So the first SU, our SU is how much? I cannot remember. It's about 18. It's about 18. Okay, it's about 18. It's about 18 multiplied with 2, about 36. So the first layer is about here 25 to 50. So the first layer should be soft clay. Soft clay. Second layer is 160 multiplied by 160 is about 320. So it's about here 2 times of SU is become very stiff. Sand here, phi equal to 33, so we can see it from this. Phi equal to 33, they have to see from n value. N value is without any kind of correction from this. So we come back to n average about here. N without correction is about 25, 24. So we see from this 25, 24 is medium dense sand. Okay, it's medium dense sand, and the last one is the n value is about 40 something. Okay, it's still medium dense also the same. So it's just change to medium dense sand. Okay, that's all for how can divide soil into layer. I in my workflow I do something like this. I hope you guys can understand what's going on, what can you do. I will give you 2 boreholes. Each student, please do it for me, and please submit to me, not in Excel file. Please transform your Excel file into PDF and submit it to me. So this one is starting point of the foundation engineering. We make the borehole, we collect the sample, and we can divide soil into layer. We can calculate the engineering property, and for the next part we will use the engineering property of the soil to design our foundation. Thank you.